Alright, the next part to this question is finding out the centripetal force. In your book, they give you a formula, and I'm just going to show you where that formula comes from. So, starting with this one here, we can substitute in our formula we already know, which is F is equal to ma. We will rearrange that one to make A the subject, so A is equal to F divided by M. And we've got an A on this one, and we've got an A there, so A is equal to V squared over R, and A is equal to F over M. Therefore, F over M is equal to V squared over R. So we can get rid of the A and put in a F over M is equal to V squared over R. Alright, now that we've got that, our last step is to get rid of the M from this side of the equation. So what we do is we multiply both sides by M, and that gives us with M V squared over R is equal to F. And that's the equation we're going to use now to find out the centripetal, or the amount of centripetal force applied to this rat as it's rotating. So that's how hard we have to pull on the tail to prevent it from traveling in a straight line tangent to the circle. If the tail was to snap, then the rat would carry on in that path, but as long as the centripetal force is in there, it'll carry on in a circular path. So our job is to write FC is equal to mv squared over r, and then we substitute in our mass. Notice I've given it to you in grams. You need to know to change that to kilograms, so 0.132 times same velocity as before. It's traveling at 3.5, and we've got to remember to square that, and then we divide it by the radius, which has got to be in meters, 0.2, and that gives us an answer of 1.617 divided by 0.2, and when we put that into our calculator we get 8.085, I believe, and we'll need to round that one to 8.1, and because it's a force, its unit is in newtons, so FC is equal to 8.1 newtons.